Hi everyone, in this video we will talk about how the simulation mode in akYtec ALP works. We will be helped by the familiar blink block from the component library. We haven't discussed its operation yet, so we will go over it briefly. While this block's input is on, rectangular pulses are formed at the output. You set their duration and the pause between them in the blink block settings. As soon as the input is turned off, the output will also be off. Remember, blink always starts with a pause. Let's see how this will look in simulation mode. Let's create a simple program where the input is connected to the output. To enter simulation mode, press the icon on the toolbar and then start this mode using the Start button. Now, pressing the input, the PR will turn on and remain on. The output will also turn on. To turn off this input, I press it again with the left mouse button, and the output turns off. Next to each element is an icon showing its current state. You may have noticed that when the input was turned on, the background of this state changed to red. This is controlled by the simulation mode setting found in the Properties panel. This is the background change parameter. Mine is turned on, meaning set to yes. By default, it is turned off. So, if you want to use this feature, don't forget to turn it on. You can also set the background color right here. Now let's add the blink block. Connect it to first discrete input. We will transmit the block's results to the first PR output. In the block settings, we will specify the duration of the on state as 2 seconds. And the pause duration as 2 seconds as well. Start simulation mode. Turn on our program. Now, when we turn on the first discrete input, the blink block will start its operation. And as I said, it starts with a pause. After 2 seconds, the first impulses will appear. And then they will continue indefinitely until we turn off the first input. When working with timers for their debugging, it's convenient to use simulation mode parameters called refresh time and cycle time. Refresh time is how often the algorithm is executed within simulation mode, and cycle time is how much internal virtual time passes during one operation. As you can see, under the blink block, the current state of the pulse and pause is shown, and these values change every 100 milliseconds. And the cycle time is responsible for this. They change from our real-time perspective every 100 milliseconds. Refresh time is responsible for this. Let's try to change the cycle time, for example, to 200 milliseconds. Notice how the pace at which the state changes has also changed. But now the pulses have become twice as fast. Because for 100 milliseconds of real time, 200 milliseconds of virtual internal time of simulation mode have passed. In this way, you can speed up or slow down the process within your program debugging. Speed up if cycle time is greater than refresh time. Slow down if cycle time is less than refresh time. For example, in my case, it's 50 milliseconds. Now, the pulses go twice as rare as it was in real time. Let's stop simulation mode and add another element. Let's take the interval timer called clock. Connect it to the second PR output. Interval timers help us turn something on or off depending on the current state of real-time clocks. In its properties, we will set the date and time of turning on. Let it be the 18th of March, 4 p.m. and the date and time of turning off, the 18th of March, 5 p.m. Start simulation mode, turn on the program, and now in the Tools panel we have added another parameter. This is the current date and time of the simulation mode. Right now, in virtual time, we have the current real-time clock value. Accordingly, the output of the block is off. Let's change the current time, for example, to 4:33 p.m., the 18th of March. We change it using the keyboard and press Enter. As you can see, the block output turned on, and the clock output also turned on. Now we can either wait half an hour until the time itself reaches 5 p.m. or again speed up this process a little bit and set a time close to 5 o'clock in the evening. Well, for example, 4:59 p.m. and 56 seconds. Press Enter and wait for 3 seconds. The output of the block turns off. Using this tool, you can debug those parts of your program related to real time. As you can see, working with the simulation mode in akYtec ALP is as simple and convenient as possible. For clarity, there is a highlight at the moment of parameter changes. You can control the internal time of the simulation mode and also debug elements related to real-time clocks. And that's all for now. Don't forget to leave comments under our videos and subscribe to our channel. Bye everyone.